Hey guys, this is Ryan. I just want to put out a quick recording about what we did on Tuesday, October 18th. It's day 31. We talked about a new technique in propaganda, persuasion, and advertising called skewed statistics. And here's what it's all about. Um, First thing is just defining what the terms are. So, statistics, first of all, is just a number representing some phenomenon in the world, something that's going on. It could be a fraction, a percentage, age, date, any kind of number that's kind of giving us information. And then the skewed part is means that it's altered in some way that's misleading. So it's biased or distorted in a way that is regarded as inaccurate, unfair, or misleading. And we'll go into a little bit more about that. But basically, another way to say skewed statistics, sometimes people often refer to this technique as lying with numbers, changing numbers to kind of make the message be what you want it to be. So here's the first step. So anytime someone is gathering data, they need a sample. For example, I can't ask every person in the whole world their opinion on an issue, or I can't ask every single American who they're going to vote for. So what people do is they choose a smaller group of people that represents the bigger population. So they choose a smaller sample that represents the bigger population. And then the idea is that instead of asking thousands of people, I can ask just a few dozen or a few hundred people. And then I can assume that the sample is going to give me the same results as if I were to ask the entire population. So what people can do to skew the results is they can make sure that the sample is going to give them the results that they want. So for example, if you think of it this way, I could go around and ask all 300 some thousand or 300 some million Americans who they're going to vote for, or I could just choose a sample. And depending on my sample, I might get different results. So if I poll students in my sample as Rise Up Community School students, I'm probably going to get very different results than if I go to rural Colorado on the Western Slope and ask people who live in a small agricultural town. And I'm probably going to get totally different results than if I go to a senior center and ask people that are all in their 60s and 70s and 80s. So what I can do is I can kind of manipulate or control that sample to get the results that I want. So that's one pretty common technique. One more thing is kind of the overriding theme here is bias. So oftentimes this is the driving factor in why people manipulate the data, skew the statistics. They want to they have prejudice in favor or against a thing or a person or a group. So they basically, this is a really kind of fancier way to say that they want to make something, someone, or a group of people look good or bad. And it can be positive or negative, like I said, good or bad. So here's our second technique. And I forgot to mention this, but there is a guided note sheet that you can get from Levi or I that you can use to take notes during this presentation. It makes it pretty simple. The other technique is choosing the average. And this is a little tricky, but if you kind of go back to your math class, most people think of average as the mean or the mathematical average. So for example, let's do a quick little lesson, how to find the average. So most people think of the mean where you add up all the numbers you want to average and then you divide by the number. So let's say we want to average these numbers on the top here, 1, 2, 3, and 6. So you add them all up to find the total, and then you divide by the number of items, and that gives us the average. So that's what most people think of when they think of the average. But if you go back to your math class, you might also remember that there's also median and mode. So median is if we lined everybody up, you took the middle person, or the middle item could also be quote unquote the average. And then also the mode could be the most frequent or the most common. So for example, if we're looking at average age at Rise Up, I feel like, I don't know this for sure, but I feel like there's a lot of 17-year-olds here. So that might be the mode That could also be the median, but I doubt that that's the mean. We'll look into that today. So here's an example of a real estate agent who's honestly telling someone that the average, who could honestly tell someone in truth that the average income of the neighborhood are all three of these numbers. And here's how it works. You may be thinking, it's likely one is mean, one is median, and one is mode, and that's exactly what it is. So this is the text. Basically, the big figure is the mean, the middle figure is the median, or the middle, and then the lowest figure is the mode, or the most common. And here's a better way to see it. So left to right, it's the most income to the least income. And you can see the true average is right here, $150,000. And what that means, it's the true average because this one celebrity is kind of pulling the average all the way up because she's making so much more than everybody else. So the average is going to be kind of distorted or not as accurate as it really should be. So that's what we see when there's like an outlier number, one number that's so different than all the others. It can really change the mean. But the benefit of the median and the mode is that that one outlier, that one $4.4 million salary is not going to affect the median or the mode. So we have this middle person. So we're not going to count, but if you counted all these people on this side of him and that side of him, they'd be equal. He'd be in the middle. And then the mode is obviously the most common. We have 20 people that make this salary. So that would be the mode. And you can, I guess you could say, you could truthfully say that these are all the average. It's technically true, but it's misleading in a lot of ways. All right, here's our third technique. So you can use graphs to send your message. And I would encourage you guys to pause and really look closely at these graphs. What you'll notice is the horizontal, or the x-axis, is the same. But the vertical, or the y-axis, is very, very different. And what they've done is they changed the scale. So you can see on the left, 1 bar equals 500 up here. But if you look over here, 1 bar equals 50. So they've almost, they've zoomed in by a factor of 10. And what it does is you see this little rise and then the little dip and then another rise. What it does is it accentuates that. It emphasizes those kind of dips, those peaks and those troughs to make it look a little more dramatic. So same thing below in the red. It's really tricky to see the red, but you can see how the scale over here is 1 bar equals 5, but over here 1 bar equals 0.05, if I'm not mistaken. So it's very, very dramatic. And obviously, if I want to show you, let's say we're talking about Rise Up Community School, and I want to show someone who's interested in our school that our attendance is really consistent, I might want to show them this, right? But let's say I want to show them something that demonstrates that we had a drop off in attendance and then we responded to it and students' attendance rose. I might want to show them this, or maybe even the red one, right? I might want to show someone like, hey, look how attendance is growing at Rise Up Community School. But here's the bottom line. The red, both red lines are showing the same information. It just appears different. Same thing with the blue. It's the same exact information. So what I could do is I could mislead the viewer by showing them the graph that appears the way I want it to appear. Here's another simple example. Same thing where the x-axis is the same and the y-axis has changed. So the scale is much, much different. Is that right? Yeah, I think so. Here's another example, just using bar graphs. This is really, really common. But what you'll notice is the graph on the right looks like a little more, like it's dramatically different. The difference between the two looks different, and the May total looks much, much lower. And really all they've done is, instead of starting the vertical, the y-axis at 0, they started at 10. So they basically kind of chop off the bottom of the graph. And this is a really common technique to make the shorter bar look really short. And it kind of makes the difference look even greater if you kind of compare the left and the right. Here's another real world example from a news show showing tax cuts, and you can see it's 35% versus 39.6%, and they've chopped off the majority of the bars below. And interestingly enough, if you actually did this from 0, this is what it would look like. So we're comparing something. If you have the entire bars, it doesn't look like a major difference, a radical difference, but if you look at this, it does. And we'll pause there. So that's what we went over. We did a few practice activities, and you'll find those printed in your classroom. Today we're going to continue. Today's day 32, so we'll continue this.